Today we're going to be working through our lesson 7.5 practice B and practice C. I've went through this practice page and I've chosen about 6 questions that I feel like are very similar to the ones that are on your quiz you're about to take, and we're going to go ahead and work through those together so you can see them one last time before you start working on that quiz. So first thing I need to do here is start with the problem number 1. That's the first one that I want to do. So I'm going to go ahead and solve this. I'm trying to get to x. Now because x is the only exponent that I have, I don't have one on the other side, I'm allowed to use logarithms here. So I'm going to go ahead and take the log of both sides. When I take that log of both sides, I'm going to have the log of 5 to the power of 2x is equal to the log of 20. Now I need to get the 2x out of that exponent, but now that it's in a log, I can use the properties of logs to say that this is 2x times the log of 5 and move that 2x to the front. The log of 20 will stay the same on the right-hand side. From there, I'm trying to get the x by itself, so I'm going to divide both sides by the log of 5. And that log of 5 on the left will cancel out. This leaves me then with 2x is equal to the log of 20 divided by the log of 5. Now these are just numbers, so I'm going to grab my calculator here, and I'm going to do the log of 20, and I'm going to divide it by the log of 5. When I do that and hit enter, I get 1.861. I'm going to write that number down, but I'm going to keep this full decimal in my calculator so I can actually get an exact answer here. So I'm going to go ahead and divide by 2 on both sides, which leaves me with x is equal to, I'm going to take this answer and divide it by 2, hit enter, I get 0.930, but again this 6 isn't around the 0 up to a 1, so I'm going to call this 0.931. Okay, so this is my answer for number 1. And I should have said this is from the practice B side of that worksheet. And most of the problems we're going to do are come from practice B. And next one I did want to take a look at is number 4. Number 4 is a little bit different because here I have 16 to the power of 5x is equal to 64 to the power of x plus 7. With this one, I now have x's in both exponents, which means that I can't just take the log. Because if I take the log and move them to the front and start to divide, they don't cancel out the way I need them to. I have x's on both sides still, and I can't get those together. So the first thing I need to actually do is I need to rewrite these to where my bases match. So I'm looking for a number that I can use that will go into 16 and 64 as that number to some power. Well, I would start by seeing if I can use 16, but 16 to the first is 16, and 16 squared is 256. So I don't get the 64. It's somewhere in between 1 and 2. But I don't want to use decimals. So I'm going to not use 16. I need to use a different number. Well, just looking at 16, I think of 16 as 4 squared. So I could rewrite the 16 as a 4 squared, and that's still being raised to the power of 5x. And I also know that 64 can be written as 4 to the power of 3 to the power of x plus 7. So I'm rewriting my two bases so that my bases match. The reason we do this is now that I have matching bases, I know that in order for these two sides of the equation to be equal, the exponents need to be equal. So I can just ignore my bases here. I'm really just kind of dropping them away. And I'm going to say that in my exponent here, this is now multiplication because of power to a power. And I'm multiplying 2 times 5x. And I'm multiplying 3 times the entire x plus 7. Okay, well 2 times 5x is 10x. And I can multiply on the right-hand side as well. The 3 gets multiplied by both the x and the 7. So 3x plus 21. I can then subtract my 3x on both sides, which gives me 7x is equal to 21. Divide by 7 on both sides, and x is equal to 3. Okay. If you remember back to when we were doing these in your notes, we were checking these. I will not require you to check them on the quiz. However, you could check them all real quick in your calculator. For example, on this one, I could just type in 16 to the power of 5 times 3. Make sure your 5 times 3 is in parentheses here. And I get this crazy answer with this e at the end. But as long as the other side is the same thing, so 6 to the power of 3 plus 7, type it in. I did not get the same thing. Did I not get the same thing? Oh, because I used 16. Sorry, I need to do 64. So 64 to the power of 3 plus 7 plus. Now I get the matching decimal, so you got to ignore the one in the middle there. So I know that those match. Now I know that those check out, and my answer is correct. Next one we are going to take a look at is number 16. 16 is where I'm going to shift to doing my logarithms, so starting with my logs. So this is the log of x plus 4 minus the log of 6 is equal to 1. Well, in order to do this, I need to get everything into one log so that I can kind of work through getting the log out of there. So if I start with a subtraction, subtraction turns into division inside the log. So this is going to be x plus 4 all over 6 is equal to the 1. And now that everything is all inside the log, I am allowed to switch forms, but I need my base here. Because there's not a base written, we assume it's a 10. So I do 10 to the power of 1 and then come back over. So 10 to the first is equal to x plus 4 over 6. Now I should simplify 10 to the first, but 10 to the first is just 10, so I'm going to ignore this exponent there. And then it starts with x by itself. So I'm multiply by 6 on both sides, which gives me 60 is equal to x plus 4. Last thing then is to get the 4 out of there. Subtract 4 on both sides. 60 minus 4 gives me that x is equal to 56. Next one, number 18. Now, I've gone back and forth of whether I want to do number 18 or not, but I decided it is similar to one that is on your quiz, but there are some weird things that happen with it as well. So we'll kind of talk through those, but you'll see, I think, when you take the quiz, what I was thinking of why I wanted to still do this one. So let's look at 18 here. I have the log of x minus 1 with that whole thing squared is going to equal the log of negative 5x minus 1. Okay, now there's a couple things you could start to try and do here. I do have an exponent. You could try and move it out front. The only problem is moving it out front. Now it's kind of sitting out front. It's not a part of the log, and it kind of gets stuck there. So I'm going to leave it where it's at. I do have a log on each side, and because my bases match, I can actually ignore these logs and simply say that x minus 1 squared is equal to a negative 5x minus 1. Once I have done that, then it just becomes a simplifying. Now you got to be very careful with your squared here, and this is the part that's not on the quiz, the fact that I have something squared. That means that I'm taking x minus 1 and I'm multiplying it by an x minus 1. I now need to distribute all the way through these first two binomials. This is also what we call foiling. So I'm multiplying the x by an x, gives me an x squared. Negative 1 times an x is negative 1x. Negative 1 times x is negative 1x. And negative 1 times negative 1 is a positive 1. That's going to equal our negative 5x minus 1. The last thing I need to do is combine my like terms on the left-hand side here. So this is going to be x squared minus 2x plus 1 is equal to negative 5x minus 1. So again, that's a little bit different than what your quiz will be. But the idea that I'm about to move into right now is the same. So I have this quadratic here that I need to solve. In order to solve a quadratic, I really do want it equal to 0. So I'm going to add both the 5x and the 1 here. I'm going to do them at the same time. Hopefully you're okay with me doing that. Okay, they'll both cancel on the right-hand side. And I'm simply left with the x squared. My negative 2x and my 5 gives me a positive 3x. And my 1 and my 1 give me a 2. That's now equal to 0. So I have this quadratic that I need to solve. Now, at a bare minimum, you need to get to an answer here. If you don't know how to do what I'm about to do, you can do quadratic formula, which again is your negative b plus and minus the square root of b squared minus 4ac, all divided by 2a. That's a lot of work though. Okay, I will tell you that anytime you see a quadratic dealing with these logarithms, I'm going to make sure it's a nice one that you can factor. What I mean by that is I can come up with my two binomial groups that will multiply back to give me what I'm starting. Okay, this is similar to what I did up here with the foiling, but I'm unfoiling them now. Okay, so I'm going to start with my x's in here because that's going to give me the x squared. Then I'm looking for things that multiply to give me 2 and add to give me 3. Well, 2 is a pretty simple number if the only thing I can multiply are 2 and 1. So I'm going to say this is plus 1 and plus 2. Okay, once I do that, I do need to get to my actual x's for answers, which are the values that make each of these expressions equal 0. So the value of x in the first one would be a negative 1. The value of x in the second one would be a negative 2. So I know my answer is one of these two things, or possibly both. Because I have two answers, I should check them. Now, I do have two negatives here, and the rule of thumb we went with before is if we have a negative, that won't work because we can't take the log of the negative number. Well, we have to be careful with what we do here because based on the equation that we have, 1 actually might work even if it is negative. So if I plug a negative in up here, I get a negative 1 minus 1 is still going to be negative 2, but I square it. That makes it positive automatically. Okay? And the same thing's going to happen when I plug in a negative 2. I'm going to square a negative, which is then make it positive. So in both those cases, the left-hand side will be positive. Now the same thing is actually going to happen on the right-hand side because I'm plugging it in and multiplying by a negative. That negative times a negative makes it a positive minus 1 is going to still be positive. Same thing whether I'm plugging in the 1 or the 2. So in this case, this is a very rare thing to happen, but both of these answers work. Okay, so both the -1 and -2 work in that situation. Okay, again, parts of that are similar to what you'll see on your quiz, but you won't quite have to do the full squaring this out and everything like that. Okay, but you will have a quadratic that you will need to solve. Next thing I want to take a look at here is actually a story problem. So I'm going to bring over the worksheet here. We're taking a look at number 22. Okay, so we're going to do number 22 here. Number 22 says the population of a small farming community has declined at a rate of 7% per year. The decline can be expressed by this exponential equation. So they're nice enough to give you the equation. I'll write that down. So I have P is equal to C times 1 minus 0.07 to the power of T, where P is the population after 2 years and C is the current population. If the population was 8,500 in 2004, when will the population be less than 6,000? Now we have done problems like this before, and when we did them before, we typed them into y equals and we looked at our table and we estimated roughly where these things are going to happen. That rough estimate is not enough anymore. We need to be more accurate than that, and with logarithms, we are able to do that. So I need to start by plugging in some values here. P is the population I'm trying to get to. That's going to be less than 6,000, so I'm going to plug in 6,000 here. That's going to equal our current population, which I'm going to say my current situation is 2004. So I have 8,500 is equal to, I'm going to simplify this, 1 minus 0.07 is going to be 0.93 to the power of T. Now this becomes an exponential that I need to solve in the middle of the table there. This exponential is actually fairly similar to number 1 that I did up here, where I have an exponent and I only have one exponent. So I'm going to use logarithms to solve this, but I need to get rid of this 8,500 first. So I'm going to go ahead and divide by 8,500 on both sides. So I'll cancel on the right. Divide by 8,500. When I do that, I'll do that on my calculator here so I can store my answers. I have 6,000 divided by 8,500. 6,000 divided by 8,500. Okay, type them in. I'm going to write down the decimal of 7.06 going to the third place, but I'm not going to lose this number out of my calculator, so I'm going to keep it there. Is equal to 0.93 to the power of T. Now, if I want to get that exponent out of there, I need to take a log. So I'm going to take the log of both sides. So the log of 0.706 is equal to the log of 0.93 to the power of T. I can now move the T to the front because it's in a logarithm, which gives me now, let's put a line here, the log of 0.706 is equal to T times the log of 0.93. I don't miss those decimals there. Now if I want to get T by itself, I simply need to divide by the log of 0.93 on both sides. Our logs will cancel on the right, and T is going to simply equal whatever this is. So the log of 0.07 or 0.706, which again is really this number in my calculator. So I'm going to do the log of the answer, which is what I just had right there. Then I'm going to divide that by my log of 0.93. And the 0.93 is exactly 0.93. That came from the 1 minus 0.07 I had up here. I'll close my parenthesis there and hit enter. Now my answer here is going to be 4.79 7996. Go an extra place there, but doesn't really matter. I need to be exact here though. Okay. The biggest thing with this is to make sure that I do not say that this is 5. If you say that this is 5, you're going to lose points. You need to give me an exact answer to at least a couple decimal places. Okay. Your quiz. I'll just grab my quiz here to make sure I tell you correctly. Your quiz does tell you exactly how to round this, so just pay attention to your quiz directions. They'll tell you exactly how to round. All right, we have one final problem that I want to go ahead and take a look at, which is going to be actually from practice C. So you can go ahead and flip your page over. We are looking at number 3. Okay, so number 3 here on the back. Okay, and this is from practice C. Okay, so practice C, number 3, I have 12 to the power of x minus 1 is equal to 20 squared. All right, so with this one, you have a couple different options here. A lot of times what I see happen is we see automatically I have 2 exponents, so I have to do the same thing I did over here in number 4. I have to get my bases to be the same. The problem is if you just start looking at the 12 and the 20, these aren't powers of anything nice, and so they're not going to work out very well. And so I actually am going to treat this more like number 1. And the reason I'm allowed to do that is 20 squared is really just a number. Even though it's to an exponent, it's still just a number. And so I only have one exponent. I can simply take the log of both sides to work through that. So I'm going to take the log of 12 to the power of x minus 1 is equal to, I'm going to even just keep this as 20 squared. I know that it's a number, it's actually 400, but I don't care what the number is. I'm just going to keep it that way. I'll throw it in my calculator later and just deal with that. So now I'm going to take my exponent, move it out front, x minus 1 times, I'm going to throw that in parentheses so it's all one thing, times the log of 12 is equal to the log of 20 squared. Sorry, right above this, I should have technically had the log of 20 squared there. If I take log on one side, I got to do it to both sides there. Okay, from there I can divide by my log of 12. That's going to allow me to get the x minus 1 by itself. And now I'm going to use my calculator. So again, I know I have that 20 squared there. So when I do my first log, I am going to square that 20. But I'm going to close my parenthesis after it to make sure that I'm done with the top part. Then I'm going to simply divide by the log of 12. Okay, when I do that, I get 2.411. Again, that's not exact. That's my rounded answer, but I'll keep it in my calculator. The last thing I'm going to have to do is add the 1 to both sides, which you can kind of just do by hand. It's going to make it a 3.411, or I can add the 1 on my calculator and round again, but it's still going to be that 411 after. So my answer here for number 3 is 3.411. Okay, so there's all my work. All right, the last thing I want to do here quick before you get started on your quiz is to show you some answers. So I'm going to put the answer key up here. I'm not going to leave it up for very long in each section, so if you need to, your substitute can go ahead and pause the video for you and then just press play again once you're ready to see the next section. So here's the first part of practice B. And you can actually see all of them there. Okay, the last part on the bottom here, I just want to make sure we put our same answer again. 4.7996. Just make sure our roundings are the same there. This is a 6 at the end. On to the back. And on the bottom here. All right, and just a couple things before we get started on the quiz. I just want to point out a couple of these. Some of these are pluses and minuses. Okay, that's happening again because they have these squared pieces that when I plug them in, they end up being positive. So both of them end up working. But the one I want to talk about here as well, sorry, my lights just went out in my room, is number 22 here. Okay, with 22, you do have to set up the equation. On your quiz, you will be given the equation. All you're going to have to do is plug in a value. So similar to what we did on the other side, where I give you some of the information that you then have to plug into that formula.